Okay, back to our demonstration. Here you see a bunch of water molecules. Whoops, I am muted. All right, back to our demonstration. Here you see a bunch of water molecules. So we have a little pond or a lake, and these water molecules are not at absolute zero, so they're vibrating around, right? All right, and what we have is dissolved oxygen in the water, O2. Now, we have a guest lecture today. Dun, 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 dun. Yes, it's a shark. And I hope you know a shark, dun, 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 is a fish. And as a fish, it has gills. And because it has gills, it can extract the dissolved oxygen from the water. Come on, shark, you can do this. Come on, shark. Extract the dissolved oxygen from the water. Yes. And swim away. Now it has oxygen to get the energy out of its food. All right, we have more dissolved oxygen, so here comes the shark. Dun, 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 dun. It is able to extract the dissolved oxygen from the water. Sure it can. There we go. It just extract the dissolved oxygen with its gills, and now it can smell that blood drop a mile away, and it has oxygen to get the energy out of the food. All right, I hope you like that little demonstration. I hope I can get back to my other camera, and I'm guessing I can't. So that is only one. All right, I will probably see you in the next video. Bye. Well, that was exciting. All right, we're going to keep going with our little worksheet. You can see I already typed in the name of the next molecule, methane, CH4. So let's take a look at this. All right, this is methane. It has 1 atom of carbon and 4 hydrogen atoms. And you see this is much more three-dimensional than our other molecules, all right? I wish you could twirl this around for yourself. So here we'll zoom in on this. All right, so this is methane, 1 carbon atom, 4 hydrogen atoms. And an interesting thing about methane, this is also known as natural gas. Some things you should know about it: it's a fossil fuel, it's natural gas, and we burn methane, a lot of us, to heat our home. So if you have a gas furnace, a gas heater, you're burning methane, breaking those covalent bonds, releasing the chemical energy. So let's see, so again, you should know methane is natural gas. We burn it, so if you have a hot water heater that runs on gas, you're burning methane. Some of you have gas stoves at home, that's methane, methane, methane. If you're an EVB major and you've heard about the environmental issue fracking, this is what they're trying to release from the ground. They pump a lot of water and other stuff down in the ground and crack the rock, and methane, methane, methane bubbles up. So this is methane, natural gas. All right, the next one I think you should know. Carbon dioxide. All right, so this is the next one, is carbon dioxide. There's 1 atom of carbon and 2 atoms of oxygen. Okay, and notice that it is a linear molecule. It's 3 atoms right in a row. Water was also 3 atoms, but it has that sort of bent or boomerang shape. So water has a different structure than carbon dioxide. All right, so some things you should know about carbon dioxide, right? We exhale it. We produce carbon dioxide when we burn wood, when we burn fossil fuels like methane, or like gasoline or coal. All right, so an important thing you should know about both carbon dioxide and methane is that they are both greenhouse gases. All right, now some people think greenhouse gases are bad. Well, first of all, remember, good and bad is outside the realm of science. But if it weren't for the naturally occurring greenhouse gases, the average temperature of the Earth's surface would be about 0 degrees Fahrenheit, like well below freezing, about negative 18 degrees Celsius. And life as we know it would not exist. So the naturally occurring greenhouse effect is a good thing. But we have pretty solid scientific evidence that humans have been burning fossil fuels, and it is that, and we have the smoking gun evidence that our CO2 levels in the atmosphere are increasing. So stuff you've heard about in the news, increased flooding due to increased rain, due to increased precipitation, due to increased evaporation, due to increased trapped heat. So record hot temperatures, increased energy being trapped, increased high-level hurricanes, increased high-level tornadoes, and weirdly, polar vortexes. Do you remember when you were in kindergarten and school was closed due to polar vortex days? No, it didn't happen. It's a recent phenomenon. Well, this is a really weird thing about too much greenhouse gases and global warming. It weakens the barrier between the frigid North Pole air and our temperate air. And because it's weakened, the cold air tends to come down. And that's what gives us these polar vortex days. So that's a lot of information. Some of it we'll cover in 152, Bio 152 if you take it. But the important thing you know is that both carbon dioxide and methane are greenhouse gases. And a little bit of this is good. Naturally occurring, nice warm blanket around the earth. But too much of a good thing is not a good thing. And increased levels of CO2 is trapping way too much energy, getting way too violent hurricanes, way too much evaporation, precipitation, and I don't need polar vortexes, seriously. All right, moving right along, we have NH3, and that looks like this. This is 1 atom of nitrogen and 3 hydrogen. And in case you don't know, this is ammonia. So I'll type that out for you. All right, ammonia. I guess I won't make it bigger. Oh, maybe I can make it bigger. There we go, ammonia. So this is NH3. Don't get it confused if you take chemistry with ammonium, which is an ion. All right, and one thing you can know about ammonia, it's a good window cleaner. We use it a lot for cleaning. And finally, this is really cool, N2. All right, if I would look at, let's say, H2, you don't have to draw this. Looks like a little dumbbell, right? 2 hydrogen atoms bonded together with 1 covalent bond. You had to draw this for homework. So you draw H2, and then you drew O2. Well, here's the freaky thing about N2. Ta-ta-da! 1 molecule of nitrogen gas, N2, so this is nitrogen gas, has 2 atoms of nitrogen with 3 covalent bonds. This is a triple covalent bond between the 2 atoms of nitrogen gas. And as you might expect, a triple covalent bond is stronger than a double covalent bond, which is stronger than a single covalent bond. All right, so an interesting thing about nitrogen gas, it's very, very, very hard to break down because the triple covalent bond. All right, and the other thing about it, if you breathe in nitrogen, you've just breathed in 4 out of every 5 molecules you breathe. We're N2, nitrogen gas, because almost 80% of our atmosphere, and I've actually told you this before, about 80% of our atmosphere, actually 79% of our atmosphere is nitrogen gas, N2. So these are simple molecules we're going to talk about in the course, and then what we're going to do is get into food next class and next week. I'll see you in the next video, and hopefully I figure out how to shut this one down. See you then.